Okay, this is the periodic table, lesson 3, and this is the last lesson in the periodic table. It's a relatively short unit. So we're going to finish up today with discussing how reactivity of elements change on the periodic table, group versus period, and what does isoelectronic mean. So we're going to discuss reactivity, which is the ability or tendency of an element to go through chemical change. Let me get my pen working here. Or this can be react, just simply react with another element. We cannot compare metals to nonmetals. That's like comparing apples to oranges. So when we talk about reactivity, we're going to talk first just about reactivity of metals and then about the reactivity of nonmetals. So as you recall, the most reactive metal is francium. And going down a group, reactivity increases for metals because we're getting closer to francium. And one of the main reasons is because there is increased shielding. Remember the whole when you reach in and grab the trunk of the Christmas tree, which balls fall off faster analogy? And it's the balls on the end of the branch. Why? Because they're less stable. You have all the balls in the middle of the branch that shield it from the trunk, which is stable. So we have this increased shielding of the inner principal energy levels, which means that valence electrons are held less tightly. They're very, very loose, and electrons are lost more easily. Which means if they're lost more easily, that means they have a low ionization energy and things are going to react, like cesium and rubidium in the exploding bathtub. Okay, going across a period, reactivity is going to decrease for metals. We are getting further from francium. No, I repeated myself. And the reason is because there is increased nuclear charge. So I'm increasing my magnet and mass because protons add mass, and therefore it pulls more tightly on the negative electrons. Remember this right here, this pulling more tightly is the girdle theory. Sucking them in. Therefore, it is harder to remove electrons. Okay, let's talk about nonmetals. Recall the most reactive element in our nonmetals is fluorine. And going down a group, reactivity is going to decrease for nonmetals. Why? Because I'm getting further away from fluorine. However, the reason being is because there is increased shielding. And it's harder for the nucleus to attract more valence electrons because the magnet is so far away. Going across a period, reactivity is going to increase for nonmetals. I'm getting closer to fluorine. And the reason is there is increased nuclear charge and mass, and therefore it is going to be easier for the nucleus to attract more valence electrons because that magnet is right there, close to it. Okay, that's it on reactivity. We're going to finish up with the word isoelectronic, and that means atoms or ions that have the same number of electrons. So let's look at F minus. Well, let's look at F. F, you know, is 2, 7, and F minus is going to be 2, 8. Neon is not changing at all, and it's 2, 8. And then we have Na plus. So Na is 2, 8, 1, but Na plus means that it lost 1, so it's 2, 8. So all of these have the same electron configuration, which is 2, 8, 10 electrons, which means that they are isoelectronic. But I want to review here for a minute. Which one of these is going to have the smallest radius? So let's look at our magnet size. Fluorine's got 9 protons, right? So even F minus has got 9. So here my magnet is a plus 9, right? Neon has 10. So here it's a plus 10. And sodium has 11. So here's my plus 11. So this has the biggest magnet, and that means it's going to suck these in the more, okay? So if we were going to do this by size, Na plus is smaller than Ne, which is smaller than F minus. Same number of electrons, but bigger magnet means bigger Gödel theory. Okay, that's it for this last lesson.